Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, and welcome everybody to another episode of the AEC Trailblazers, where we interview the most amazing founders of the tech scene of the AEC. Today with us, we have Joe Scanlon. He's a tech entrepreneur. Joe founded Scanalytics to revolutionize building intelligence. Scanalytics smart flooring sensors provide unparalleled insights into space utilization, enabling buildings to adapt to occupant behaviors. With a background in neuroscience and a passion for innovation, Joe is driving the future of smart buildings. Outside of work, Joe is an avid triathlete. We have that in common, Joe. He enjoys jiu-jitsu. We don't have that in common. He fights. Likes pretty much anything with a motor, then can go fast. His most important job is being a father to his baby girl, Sloan. Hey, Joe, welcome to the show.
Thanks for having me. Appreciate it.
Did I miss something on the bio?
No, it's all good. Since writing that, I now have 2 additional kids. So I have 3 total. My daughter Sloan still, and a son Dominic, and another daughter Ivy.
Nice. Congrats.
Yeah, thanks.
Where are you based? You can tell everybody where are you based.
I'm in Grand Rapids, Michigan, and our company is sort of distributed, but we have our kind of center of gravity in Madison, Wisconsin.
Nice. I want to learn everything on how a guy who has a great background, first of all, secondly, comes from neuroscience and then got into smart building. So can you tell me a little bit about your story, Joe, how everything started?
Yeah, of course. And I get that. I also tell folks that I think naivete played an important part and role in starting, the company and getting into spaces like flooring and building materials and trying to combine technology with that. Because I think if I knew everything that I now know about it, it would have been a more difficult decision to jump off the cliff, so to speak. So yes, Scanalytics sort of was formed really on the basis of like 3 major observations that tie to the background that you mentioned in neuroscience. The first being, it's inarguably one of the largest asset classes on the planet, but it simultaneously is the least measured, or one of the least measured, right? So, I mean, the cars that you drive today will likely have more sensors in it on a per square inch or per square foot basis relative to the person's position than the typical building that you'll walk through. But we spend far more of our life inside of a building. And so that was sort of a curious observation. The second was it's also has been for the longest time the single largest contributor to global greenhouse gas emissions. So that observation also came from sort of, the question of like, why is it still that? How hasn't it, improved? And that ties back to measurement again. And then I guess the third observation was that it felt like those 2 things could be solved. More value could be extracted from the buildings we spend so much time in. If there was a better, universally applicable technical infrastructure for understanding what's happening inside of buildings. And so with that, the question posed of how would you do it? The neuroscience thing came down to, well, what would it look like or how could we build the silicon equivalent or the technology equivalent of a biological brain for buildings? The idea of smart buildings or, brain for buildings is certainly not novel to us. That's certainly not like the first ones to think about how to do that. But when we looked at the space in particular, it seemed like a lot of the reasons why there hadn't been a brain for buildings that was sufficiently scalable was for a few kind of common limitations of existing technologies. Because when we got started, we figured we could just fuse together a bunch of feeds from sensors that are already in the space. Instead of like going in and having to build our own hardware. But we believe that hardware is the primary instigator of value creation in the space. And we think you can't get smart buildings without the best hardware and sensors to do it. And so those limitations of those existing sensors, things like, privacy issues of, that come from inherently from things like cameras, resolution and accuracy. So that might be that you could sufficiently build a basic heat map through some of these technologies, but to build a brain, like you want as much dimensionality from sensors as possible. You want to know more than just an approximation of where people are at. In this particular case, ideally you could reconstruct every single footstep. You could tell a lot about the attributes of the actors walking through the space, and you ideally would be able to capture infrastructural things. So being able to understand what is the environmental conditions of the space and how is that changing the behaviors inside of them. And so with that question posed, we sort of asked ourselves, well, okay, if we're going to have to build this ourselves, what does every single building that's ever been built have in common with every building that will ever be built? And to us, that narrowed it down to surfaces. They all have floors, they all have walls, and they all have ceilings. And so to put a bow on why we chose flooring, the more that we looked into it, and my background as a serial entrepreneur is true to form, where you learn that distribution is really all that matters at the end of the day. You can build the best product, you can build the best science, but ultimately, if it can't be cost effectively distributed, you don't have you probably don't have the solution that's going to solve the problem at scale. And so flooring had this unique combination of the flooring industry had this unique combination of routine entry points or touch points within the building stock, because especially commercial buildings get refreshed flooring, every 5 to 10 years. So that equates to like billions of square feet of flooring that gets sold and installed every single year just in North America. And that it's a fundamental layer in every building. So we don't think it's going anywhere. We don't think the advent of AI or software or anything is going to change the fact that every building has a floor and every occupant of that building navigates the building by walking over the floor. And that it has annual volumes that eclipse any other technology that we could see. So those things sort of combined, gave the premise of starting Scanalytics and building this kind of combination of smart flooring sensors and the software and data abstraction layers on top of it.
Really interesting, because for sure you took the hard route. Nobody wants to do, like, if they can avoid it, to do software and hardware because it's harder. Yeah. You said like it's much easier to just build on top of another platform, right? But you had your good reasons for it, and I'm just curious. You tried at the beginning using all the sensors, and then like you were not able to actually get data out of it, like precise, like you said, for example, cameras, like you need multiple cameras, or if someone is behind a desk or something, you're not going to get accurate data. So how far were you compared to sorting the floor? Like it was like similar, or it's like huge?
We didn't have to get too far in before we realized that it wasn't going to be the solution, in part because we didn't want to build a sort of Me Too IoT device. So we didn't want to build something that adopted also ultimately the same kind of competitive business models that when a new IoT device for buildings come out, at least in our observation, they might claim that there's like a new thing that they can measure, or it's a little bit easier to install than the other folks. But ultimately, they all again suffer from similar issues with distribution, where they have to raise significant amount of capital, for example, to actually distribute those sensors, because those sensors aren't necessarily a required or necessary component of the building. In many cases, they're very easy to install, but what we noticed was the feeds from these sensors, especially if we had to fuse multiple of these together that we didn't control. Like we didn't control that piece of hardware. The more that you add to that, the more uncertainty your formula is based on. And if the output, which in this case matters a lot, the data output of what's happening inside your building, if that's predicated on a bunch of these devices that you don't control whether or not they're going to survive as a company or sensor, but you also don't control ultimately what the data flows are unless it's an absolutely open source project. So those just sort of disqualified it from the beginning because we wanted to do something that we were willing to absorb the technical difficulty risk at the onset in exchange for what we feel like is a much bigger opportunity after the fact.
Interesting. And then when we were speaking about the data that you can extract out of it, the first thing that comes to mind, right, for sure, it's occupancy and then the volume, the amount of people that go through it. But is there anything else that you can infer out of it, like behavior and how people interacted because of the way they're like, they're not going to bump into each other, but you put this on central station and you can see the flow and so many variables. And I'm just curious, what are the data you extract out of it?
Yeah, so it's ultimately the newest kind of version of our hardware, at least, came from as a result of the program that we were in with the Department of Energy. So it's a spin out of the Department of Energy's Advanced Research Program Association that we were selected for and went through a couple of contracts to develop a technology that, to your point, wasn't just a kind of estimation of here's rough volumes or rough occupancy. And so what we learned is that if we were going to reconstruct with superior kind of sensor, output and dimensionality, we needed to have a resolution of a certain amount. So our most recent technology is about a 4-inch pixel resolution. So you can kind of imagine wherever these sensors are covered on the floor. In some cases, they're covering the vast majority of the building, and in other cases, we only need to cover key entry exit points into controllable zones of buildings. But that 4-inch pixel resolution is an important component because it allows us to pick up not just an individual presence of something, but it allows us to actually build these reconstruction algorithms that allow us to do things like object classification and identification to disambiguate between individuals. So again, I wouldn't know your name and my name and assign that, but I would be able to know that it is me and that's you as two discrete individuals who are walking past each other. We could come really close in conversation, and pass through, and it'd still be able to reconstruct all of that, as well as things like if I'm pushing a caster wheelchair or if I'm pulling a roller bag. The sensors have a high enough resolution to be able to reconstruct that. So in the case of occupancy, you don't want to count a moving object of a bipedal person like me pulling a bag as two people. You'd want to count that as one person and not count the bag. So that pixel resolution allows us from the sensor level to reconstruct those types of activities and objects. But by virtue of being on the floor and it being the kind of largest surface area of the building typically, it also gives us the ability to do some unique things like leak detection through different inks that we can use that are embedded into the sensor. So if there's moisture buildup or leak somewhere, instead of just having a sensor put where you think leaks will happen, the floor is a perfect kind of spot to pick up where that might be happening, and doing that across the entire surface instead of just key areas. And all of those things can basically be built into going back to the kind of brain side of things. It's sort of the stream of consciousness for a building, right? So all these events are being captured and available for different applications to pull out of that stream of consciousness and build a specific use case for. So, for example, senior living, what they care about is running a more profitable facility as a building owner, but they also care about delivering better care to patients. And to them, the same underlying sensor, floor sensor technology that is helping them reduce their energy waste in their building, thus helping them save money on their energy bill, can also be used simultaneously to help them better understand for example, the progression of a neurodegenerative disease through gait analysis over time, or predicting a fall before it happens based off of key insights that are coming from floor sensors like stride length and walking speed and number of steps. And those things can then be built uniquely into a different application that can extract value from that space. And that's ultimately what we're looking to do, is build something that eventually developers who have, way more ideas or smarter than us can build applications that exploit the kind of unique properties of the sensor and build the first scalable smart building solution, which means ultimately being able to pull in other sensor data that we might not provide is something that we can certainly support on our platform.
Oh, that's so really interesting, because like the case that you explained of like, hey, on a just checking if someone might fall or even falling, right? Like I would love to have this on my grandma's and make sure if actually she lives alone, and if something happens, I can just get an automatic call or something. Or I feel like a good example was those guys who use Amazon Alexa, to basically analyze if someone was about to have a stroke. Did you see it? Mm-hmm. That was insane. It was not Amazon doing this. It was they opening their API and allowing people to, I can use it for this, that there are so many use cases that it's impossible for you guys to do it alone, because it would take you so much time. So I don't know. I'm a really big fan of like Arduinos and Raspberry Pis, and I play with all that. So it's really interesting how much you can do just by using a smart flooring. And I'm just curious, how do you? I know it's a naive and a stupid question, but when you install this, do I need to like put the sensors and then the carpet? Can I use it with any type of flooring? What happens if I have a heat inside the slab? Does it affect the way it measures the data?
Yeah, no, great question. So we also figured when we were building the underlying technology that for it to be successful at scale, it needed to be able to be treated basically the exact same as like a typical flooring underlayment, right? So a typical foam or scrim based underlayment that can be installed on top of the subfloor of a building, and flooring gets put on top of it, which is a pretty common practice today. So before we even went to our kind of unique distribution model of working with flooring manufacturers who distribute flooring, billions of square feet of flooring every year, we figured before we go to them, we need to be able to demonstrate that it can be used without impeding their existing workflow, right? So I know this being in the AEC industry, but it's comprised of some of the most risk-averse, types of companies and folks on the planet, right? It's been, flooring, especially flooring, right? It's this legacy building or legacy business that hasn't changed for, over 100 years and doesn't necessarily need an excuse to change, right? And so we approached it where the technology that we've developed can be basically embedded directly into the typical, like if you put our foam underlayment next to a typical one, it would look the exact same. It would weigh nearly the exact same. Most importantly, though, the labor chain doesn't have to change their practices or skill up to be able to install it. They can roll it out the same way. They can cut it to shape the room the same way. And it allows us, after the fact, a Scanalytics associate can go by and hook up the readout electronics anytime, post floor installation, which was a really important part of this journey because we had to go through all of the typical certifications that, what I learned real fast was how hostile the floor is with respect to how much it is, gets beaten up by not just foot traffic, but, driven over or, leaks or fire or whatever. So our technology has gone through the same kind of traditional flooring certifications like moisture and fire pH level and humidity and all of that, so that we could actually, come to the market by saying, hey, look, this is a technology that most of the risk or all of the risk has sort of been underwritten by the Department of Energy work that we did, but also it's in a format that is suitable for the existing workflow of these the flooring kind of installation market. So of course, I suspect future edge cases where we will learn how something can break, or in a building something can happen. But what we've been lucky to have now is it's been in spaces for in some cases years, where it's been exposed to Midwest winters, and has been exposed to extreme weather. It's been exposed to a lot of foot traffic. It's been exposed to being driven over, and it's done a nice job of surviving all those conditions. And I think last note on that is we made a conscious decision to design the technology so that the readout electronics are all pulled off to the edge. So embedded in the surface area is not any sort of like important chips or components that, if they are at all disturbed, you would need to lift up the flooring to address. A very rare case, like realistically, it would take something destroying the top surface of the floor to destroy our sensor underlayment. And it comes as sort of in two versions. So most of the flooring, of course, that we deal with in the commercial side is sort of the soft surface, like carpet tile, luxury vinyl tile type of flooring. But we do also have a version that uses a slightly different underlying technology that can work underneath, like Jerusalem tile or porcelain or ceramic. The types of surfaces that are nearly as flexible as soft surface.
Interesting. And I'm curious, you get all that data. What about noise? Can you, based on the vibration of noises, can you?
You're exactly right. So another, as you can imagine, leak is the example of leak I gave is really just the use of a slightly different ink in the sensors that's exposed to the subfloor, so that if moisture or water or liquid of any kind makes contact with it, that can be read out. Well, very similarly, as you're describing, vibration and frequency can be measured through frequencies and sound versus, like, obviously we're not recording audio, but sound's important for infrastructural considerations. It's also a unique element for measuring. Let's say a commercial building wants to know what areas were actually cleaned, like vacuumed, right? So you could vacuum over a space that has a smart floor underneath it, and you'd actually be able to know this got vacuumed just based off of the the vibration profile that's being measured through the smart floor. It's fine-tuned enough that, as you can imagine, being able to determine even like a finger snap versus a fist that hits the your desk or whatever. And so that additional kind of layer, as we mentioned earlier in our discussion around dimensionality, is so important, is that we want to make that dimension an available sort of feature set for future developers that might say, hey, look, I'm building a solution that I want to be able to deliver to industrial spaces where noise matters a lot for predictive maintenance on equipment. And so those are things that can be supplied by the smart floor as well.
Interesting. And even when you're not recording voice, technically you could detect words like, I don't know, help, or whatever word you want to use in case of an emergency. And even when you're not recording, you can detect on the spot and I don't know, use something or users be able to configure it in some sort of way, right?
Yeah, as you can imagine, one of the use cases that we're passionate about that we haven't commercially deployed yet, but I just today read another unfortunate piece of news about a high school shooting, and I come from at least part of my military background has informed me of things like when you have a bad actor like that or a situation like that that's chaotic. What matters a lot with respect to ultimately what the casualty count is how fast emergency services can address the threat. Unfortunately, today with all the chaos, like they have so many feeds. Like let's say you are a police officer that's going towards that high school. you're trying to figure out, hey, 2 minutes ago, I got information that the shooter was in the West Wing, but 5 minutes ago they were in the East Wing. They're trying to discern and synthesize all this information in a really high chaotic, high stress environment where the building knows all that, right? Like the building knows where students and kids might be congregating. It knows where a lone wolf that might be the shooter is wandering through the hallways. It knows all those things, but up until this point, it hasn't been able to communicate it. And so with something like a smart floor, the ability to have that information be sent to incoming emergency personnel in real time, they have a much better understanding of where are people at in the facility currently right now, where are there kind of these aberrant behaviors or things that might indicate that they are the threats, which again might just be that it's someone wandering the hallway at a certain pace that is not congruent with everything else that's going on, and they can focus on that. Where, similar to your point, if you hear people yelling or screaming, and it might be a fire or something, having the building be able to deliver that context in real time in a real time kind of stressful environment like that, we think will be a really unique kind of new understanding of space, and more importantly, understanding of how to plan for and ultimately reduce casualties in scenarios like that.
That's really interesting. And I don't have a background in neuroscience, so this might be really dumb, but like technically you could even anticipate that happening because due to the behavior of just a specific person that, I don't know, like walks in a specific way, behaves in a specific way, is just alone all day, and I don't know, stuff that it always happens when someone is going to do something like that, and you might be able to help that person to avoid doing something as terrible as that. Yeah. I don't know if that's even possible.
Yeah. Well, yeah. So that's sort of you're describing sort of like behavioral residue, right? It's sort of like what are things that might not be conscious to who's doing it that are early indications of something like that, right? So it comes down to a couple of years ago, we had a jewelry store that wanted to use the sensors for people would go in and case the jewelry store, right? Like which means they'll go in and they'll have no intention of buying anything. They're literally going in to kind of capture intel on the space, how many people are there at any given time, and what they might smash and grab if they're going to come back and rob the place. They wanted to be able to say, I want to be able to predict that. So if I see this odd behavior, I want a notification maybe at when it's happening or at the end of the day to say, hey, look, the threat of a potential burglary is higher because these behaviors have been shown before. It's the same concept of when we're talking about the progression of a neurodegenerative disease and how it exhibits itself through behavioral patterns and just skeletal gait, right? So if it takes me typically 10 steps to complete a 20-foot linear path, but if you know that I have a higher risk of a neurodegenerative disease like dementia or Alzheimer's, it's really important for my caretaker to know that over a 14-day period, it's now taking me twice as many steps to complete that same 20-foot linear path. And it comes back to the saying that an ounce of prevention is worth a pound of cure, right? Which is like, if you can identify something as early as possible, you can attenuate it much more effectively than if you are just taking lagging data, lagging indication, which is, to me, it's so silly that buildings are predominantly, the decisions are based off of lagging indications. What has happened, over the last week or month or years even, and we're making decisions in this current window of things that are lagging when so much new information has been created in that period of time.
Yeah, and if you're lucky, that happens if you're lucky. Like most buildings, my feeling is that general architects, yeah, for sure, there are certain norms that you need to, there are like minimum sizes of rooms, and they're like, hey, we used to do buildings with certain materials because of fire, but nowadays you have to do something because otherwise the structure might fall down. And there are so many things. But at the same time, I don't foresee, or at least of all the architectural firms I've worked with, is most of it is just a gut feeling. It's like, as long as I can do it, then I'm the rest. I'm just gonna follow my gut feeling, and for me, it's just insane because we should evolve all the time the way we design buildings. Like there is no way that like buildings sometimes are slightly similar as they were 50 years ago. There is no way. There is no way that's happening because so much has changed over 50 years that there is no way we have not learned anything. So, what do you think is going to happen with design in architecture? I don't know if you may already have a couple of examples of based on the way people behaves on I don't know, offices or apartments. Do you foresee that a lot of changes coming from that data are gonna impact on the way we think buildings?
Yeah, I think we are oftentimes approached by folks who are doing really interesting and impactful research in areas that in like the built world that can't really like complete their research or findings without tying it back to again what sounds simple, but the reconstruction of how people are moving through space and time in buildings, right? So one example I thought was super interesting is we were approached by a team that was trying to understand after and during COVID, trying to understand how microbial communities, like how pathogens and everything sort of evolve and move through space based off of the fact that something like 60% of particulate matter in the air is a result of resuspension from walking over the floor, right? So it's this idea of if you want to contain the spread of a communicable disease or something, it stands to reason that you'd want to know like how are people interacting with each other in that space? Where are they moving? How much are they moving? How often are they moving? And so I believe that it'll turn into this concept of building a sort of, which is ultimately what we're doing beyond some people I think read our story and think, okay, it's a floor sensor company, and which is fair without some context. I think what I would like the walkway to be is look, we're building the world's largest regularly updating corpus of data on spatial intelligence on buildings, right? I think that will lead to what the way that we interact and design space. I think fundamentally will be informed by that context because again, you have intentions as a designer and architect of how a building will be used, but not a lot of bridging to its active use or its steady state operating conditions and use. But it can impact so many things. I mean, being in the space, what keeps it interesting every day and allows it sort of offsets some days where where you feel like you're chewing glass or nails is like that you can see the impact that just the amount of time that an occupant of space is getting natural light, or the amount of time that they're interacting with another person, and how that impacts downstream productivity and happiness and all these things. That to me, those are all have been things that people trust the science when it is studied in sort of a vacuum, but have been waiting for the ability for us to have a better understanding or better reconstruction of space so that we can be more active about that as designers of space. If we knew it beforehand and knew how it would change on an ongoing basis, I think we would definitely change the way that we design and build spaces.
Yeah, or even adapt. I feel that, for example, offices, right? Offices, we used to have these tall walls that used to separate one desk from another. Then, like, everything was open space. And now they want to do high walls again. So it's like we cannot be experimenting this way and making thousands of companies do the same and then go back. Or, like, there should be an easier way. Just experiment in 2-3 offices, and then we can replicate if we see that it makes sense. And I also do think that even when technically you cannot know who's who, but at the same time you can, because you can like tag the patterns of someone, or even, I don't know, merge the data that from a camera. And then if someone doesn't want to have anonymity, which for me, it's fair. Like if I'm the architect or I'm the leader of WeWork, for example, or any other type of big space office, I would love to see how what I do in terms of the design is impact how people work. Like it's more efficient, it's less efficient, goes more to the bathroom, it's has more depression, speaks more to people,
Right.
for that, sometimes if I want to make an action specifically to, let's say I have an employee and I want to tell the person, you know what, you're a great employee, but you need high walls because you get distracted, man. And it's your case specifically. I need to change that just for you, and I do foresee that as well happening, because sometimes you need that get rid of the anonymity and take actions to improve, employees' work as well. So I don't know. I think that mix is going to be interesting.
Yeah, and that's our approach was sort of like right out of the gates, we're sort of like inherently privacy preserving. However, to your point, like in the case that anonymity is sort of like operationally disregarded on purpose, like in a senior living facility, they do want to know who it is, the patient, right? Because they want to be able to reconstruct and build a better, more informed profile of that resident so that they can deliver that resident better care. And so in those cases, it's actually nice because it's a nice combination between high resolution information, but not an image capture. So we are never there's not an image that we're tapping into and seeing. It's really a floor up kind of digital reconstruction of how they're moving and footsteps, and if they're going to bathroom too many times in a certain period of time, is that leading to a UTI? Those are all things that can be captured without having their personally identifiable information, like their face, captured. So,
yeah, no, it makes sense. We don't want people, using this in public spaces where they can know where everybody is at all times. So we don't want that future. We agree on that. But
totally.
What about using this technology now that we speak about public spaces? That you're considering this using it outdoors or in public spaces as well?
Yeah, so we have done installations, although sparse. We've done them outdoors before, and for events and things where they wanted to understand bottlenecks and for security management and those types of things. We do think, again, the same underlying reason why you would want a better measurement for spatial intelligence within buildings, it applies, out of buildings as well. Out of buildings could be spaces like city planners that care about, sidewalk usages, public spaces like that, so that they can deliver a better design for the entire community. And that technology is very much achievable. We've deployed our own technology, but there's also achievable derivatives of our technology, like deploying basically like a graphene based paint, which is read out the same way as almost like an open closed circuit sensor, but the physical format is in a way that can be you put on top of like exposed concrete or asphalt or whatever. And so, I think, again, the more that you can also capture what's happening outside of spaces and inside of spaces, you're creating more data points to draw an arc. And that's what we think is most important, is being able to say, if this is what's happening and this is our new understanding of this, how can we be more proactive about, indoor and outdoor, and deliver a better experience, whatever that is, for work, play, or rest, or whatever.
Yeah, no, because I foresee this a lot for crowd management. Like, crowd management is so hard. And I once met an engineer who was in charge of crowd management for Mecca in Saudi Arabia, and it was insane, the complexities of doing it, and with all the sensors and everything, accidents still occur. So I guess something like this, or the same that's happening. I don't know if you're a soccer fan, but the America's final of soccer here in Miami, it was a mess. Like a lot of people tried to get to the door without a ticket, and then security, when they realized there were thousands of people just on the doors, they had to open the doors, and everybody got in. It was kind of a mess, and they could have just realized that with sensors on the parking and getting the amount of people that were out there. And it's like a lot of people are trying to get in without a ticket. That would have been much, much better. Like I foresee this being a great tool for that.
Yeah. And then, right. And to your point, then you can coordinate more with other kind of smart building infrastructure, right? So in that particular case, the floor could inform the doors themselves, right, to close or lock or do whatever, so that it's not only about deploying human kind of capital wherever you need it to address those issues, but yeah, the kind of common theme that we've been describing here is if you have information that can help you build models, analytics is sort of, you've got historical, which is valuable for some use cases. You've got real time, which of course is valuable for other use cases. And then you start getting into predictive analytics, of course, which kind of what we're describing around being able to get ahead of, things like this. And then you've got prescriptive analytics, which is like beyond predictive, is when you have it smart enough predicting that you can actually try to prescribe how the space is going to be used. That's where it gets incredibly interesting, because you're doing that without necessarily increasing your cost basis of the amount of people you need to do that. You're really doing it off of the context that's coming from the building itself.
Oh, that's incredibly interesting. I don't know. There is so much you can do, and also I don't know what you're planning. I know that data is going to be anonymous, and I bet the data is going to belong each of the buildings, I guess, but and do you foresee that you're going to be able to provide data or sell the data in a way that, I don't know, let's say I have a building and you tell me, you know what, if you, I don't know, give us your data, we give you, I don't know, 20% discount, and then you do the same for many buildings, and you don't sell the data of the building, but you sell a data set with anonymous buildings. Because that could be gold for many design companies on the AC.
Yeah, exactly right. So one of the abstractions of value, or as we thought about it, the first kind of part of this kind of flywheel of value creation, in our opinion, is getting the sensor kind of capabilities and coverage and density up, and covering volume. So getting as much space as possible covered. That's sort of like first phase, because if you have that, then you have a kind of defensible mode, but you also have this, again, creation of this regularly updating corpus of data and information. And then the next layer or abstraction of value is exactly what you're describing, which is once you have that, and you have it at the resolution that we're talking about, because today a lot of even alternative data sets that are used to make public equities decisions are things like satellite imageries of cars and parking lots of Walmarts, right? And that's a very coarse data set, but it's been sufficient to, at least in combination with other data sets, to be able to more accurately determine what Walmart's earnings might be before they come out, right? And make an extra. What we think is truly unique about when we get to the point where our volume, especially segment specific, but even just kind of real estate specific, is that we'll have a lot more contributions to that, other than just the here's roughly what's happening. But we can say, if we've got the sensors in a major consumer electronics show or something like that at a trade show, that's a completely different, that's more of a temporary installation of the sensors. But the behavior at major trade shows is a good kind of leading indication of what's going to happen in maybe physical retail buildings for the next 6 months or preceding 6 months. That's a bridge that we haven't seen anyone kind of capture that we think is really interesting, is because of the type of data that we can capture while keeping it anonymous and not selling, of course, like, one customer's or competitors to another's, is what can planners and architects and designers and, online, offline attribute companies, like what can you do with that information at a more aggregate level? And how will that play into, frankly, how does that play into monetization so that the direct building stakeholders, the owners, operators, don't have to invest nearly as much in having a sensor system, because a lot of the cost is being defrayed by the way that the data is used at scale, which is, we think, a pretty important component of all this.
No, absolutely. I foresee this on any shop, like not only supermarkets, but any shop. Like, hey, what if I move this to here and this to here, and how people behave? So what, and it's because of the location, it's because of the product, or like there is so much it can be done that nowadays it's like you said, it's post-mortem. It's like you analyze and you try on different shops, and then maybe for next year you plan how you're gonna do it, but it's not live. It's not something that you can just test it out from 1 week to the other and then automatically adjust it.
Right, exactly.
And I foresee that happening, and it's going to be a direct return of investment for clients that have commercial buildings. So, interesting.
Definitely.
Much it can be done. I'm excited for the day we can play with something like this. With data.
Yeah. Well,
you have an open API or something, or what's the current status of that?
Yes. So we actually have, the other layer, if you will. One is, like, as we described, kind of direct building stakeholders. How can we deliver value directly to the owners and operators of the space? Which, and today it's a lot of what we discussed, and it's also purely just helping them reduce their energy bill through optimized HVAC integration, and then specific use cases. The data model that we just described, and then that other layer is this kind of open spatial API. So the ability to say, hey, look, here's access to information that you can either be by segment or specifically for an application that they want to build. And we've had already, we kind of have like a wait list of developers who have come already with great ideas that we didn't even think of. In fact, we have one that's a commercial vacuum cleaning company that has described a use case where they want to better optimize the uses of like a robotic vacuum cleaner for commercial spaces, where today it's typically they map the space out and then they operate automatically to clean that space. Well, that's great and all, but of course, like, not the whole space was used every single day, and so you have wasted energy, you have kind of wasted kind of robotics bandwidth that you could use for other things, and potentially wasted costs that could be saved through understanding, what they want to do is then build the context of what was actually used in the building that day, so that they can optimize cleaning schedules with their people, but then so that they could use robotic vacuum cleaning devices to address the places that actually got foot traffic. We had another one that actually built a startup on top of it that was for manufacturing spaces. So workspace optimization. So simple things like being able to measure how people were working on a manufacturing floor, and if there's inefficiencies that could be addressed, like a particular work unit was walking multiple steps over to grab tools multiple times throughout the day. Well, they could see that over time, readjust the space design, and that might be a half a point of efficiency boost for that manufacturing floor, which half a point for manufacturing floor is like a huge lift, right? And we've had what we intend to do to kind of continue to facilitate this type of innovation is host. We've done it in the past. We'd like to do a lot more. Is host hackathons. So basically, able to say, look, here's the sensors, here's the API. You can even bring other sensors to integrate with, but who builds the coolest thing in 48 hours? And you'd be surprised. I've been surprised at just human ingenuity at college level all the way up to senior developers that can build some really interesting stuff.
It's just insane. Like, we have been part of many hackathons, and sometimes it's not even about the team that knows more about software development. It's just about pure creativity, and it's just insane the solutions that people come with after like 24 hours or 48 hours, whatever. It's just crazy.
Yeah, totally. Right.
All right. Joe, I don't want to take more of your time. I know you're a busy guy.
I appreciate it.
Running your company. But before we wrap this up, can I ask you a couple of ping-pong questions?
Yeah.
What do you think is going to be the next big trend in the AC or space design in general?
It's probably self-serving, but I do think context context of what's happening inside of space will be a big change. But outside of that world, I think 3D printing will have a new emergence, and robotics. I think that'll be a big change in the AC industry over the next couple of years.
Yeah, absolutely. If you could collaborate with any person in history, which person would you choose?
So this might be an odd one because it's like outside of the AEC industry, but I would want to work with this person on a project in the AEC industry, which is Amos Tversky. So he's he's like an intellectual colleague of the late recently late Daniel Kahneman, and so he's been he's in cognitive psychology and particularly like judgment and decision making. And I think that it would be fascinating to work with him on a project and how he approaches design of space based off of heuristics and cognitive biases. And if he had access to information like we might be able to give him, I would love to see his mind work in the AEC component or context.
That would be interesting. If you ever make it, just let me know what's the outcome of that, because it's so much interesting.
Yeah.
And then finally, what's your favorite building, and have you ever visited?
So I haven't visited it, but I think in China, the Shanghai Tower. So I think it's the largest building in Shanghai, but it also has the like double skin facade with but maintaining that kind of really interesting twisted sculpture like form. So I think it's an incredibly interesting blend of aesthetics and performance that I'd have to imagine was an extremely difficult project to pull off. So I'd love to visit it. I have not, but that one comes to mind.
Interesting. Yeah, that's a really cool building for sure. All right. And before we say goodbye to each other, can you tell everybody where they can know more about Scanalytics or contact you?
Sure. So Scanalyticsinc.com is our website, which doesn't have nearly as much information as we discussed on the podcast today, but also my email is just joe@Scanalyticsinc.com. So that works too.
All right, Joe. Thanks so much for sharing all of this. It was an exciting episode, man. What you're doing is so interesting. It's like you said. We think it's like it's just a floor sensor, but it's so much more than that. It's so much more than that.
Yeah, well, I appreciate the opportunity, and especially like talking to someone who knows the space well, and hopefully in the future we'll use some of this information to create some really cool spaces.
Absolutely. Hope you have a great afternoon. All right?
Yeah, you too.
Okay. Bye-bye.
Bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.